Hello, good afternoon, everyone. Myself, Jafar Sadiq Ali, professor working in Srimati Kumar Institute of Technology in the Department of Electrical and Electronics Engineering. Today, I'm going to take the topic Unit 3 of IoT Concept Application subject. The topic is now I'm going to cover is RFID and wireless sensor networks. Later on in the coming lecture series, we will see the rest of the things. So now I will go on straight away to the RFID. So IoT protocols RFID is nothing but is a radio frequency identification device. Its full form is a form of wireless communication that incorporates the use of electromagnetic or electrostatic coupling in the radio frequency portion of the electromagnetic spectrum to uniquely identify an object, an animal, or a person. It's mainly to detect the presence of object or a animal or a person uniquely. So it has a unique identity for which we are going to use this RFID. It uses the radio frequency to search, identify, track, as well as communicate with the items and also with the people. It's a method that is used to track or identify an object by radio transmission uses over the web. So data digitally encoded in an RFID tag, which may be read by the reader. So here what I'm understood is that in the any device, if you go to shopping mall, in any items you purchase, there's a RFID tag is embedded into the object itself. So you need not go to the main tail counter and to get the billing done. This RFID itself, it's connecting over the web and working on the radio frequency, right? So this will be reading the price of the tag anywhere inside the shopping. So this device works as a tag or label during which data read from the tags which are stored in the database, and it is read through the reader as compared to the traditional barcodes and QR codes. Here you see the one thing, traditional barcodes means what? There will be a series of bars will be embedded at the backside of the, if you purchase a book, it will be in the backside of the book. If you purchase any items, it will be either the bottom of the object or whatever maybe. So this barcode identification is scanning is required a line of sight from the scanning machine to the that particular object, and same as with the QR code also, it will be having a same line of sight, then only it will work. But our RFID, it is need not to be a in line of sight, it can be out of the line of sight also. It is easily work because it is going to use the radio frequency which will be communicating through the air from one place to another place by the use of the antenna. See here, it will be more clear if you see the picture. First top picture says the right hand side is RFID tag, that is the object that you're going to buy from the shop or whatever it may be, and RFID reader in the middle. So which consists of two things. One is scanning antenna, and also it has its own reader. So these two are communicating using the radio communication, wherein the left side portion it use the IT systems or application software and is making a communication with the RFID reader only through the digital communication only. So there are two communication happening in order to complete their full transactions. One is radio communications, that is in between RFID reader as well as RFID tag, and the other one is the digital communication between RFID reader as well as application software, that is IT systems. The bottom picture also conveys the same thing. You have the RFID reader scanning machine, Inside the scanning machine, again an antenna is there which will be propagating, transmitting as well as receiving the radio waves. So RFID is the actual thing that you're going to asset you're going to purchase. Inside that asset, there is a some set of tag will be embedded into it and stored into it. So that will act as a again an antenna which will be transmitting and receiving the signals through radio wave only. So finally, after once the data is being read by the RFID reader, it will be fed into the computer database. That is what the two figure represents the entire working principle of this RFID. Again, this same thing, it shows the right hand side is object is to be identified, which has RFID tag, and the tag is having some chip over it in which the data is getting stored. So the antenna, the tag also will have some antenna, and also in the left hand side you have the reader also you have some antenna. So these two are communicating with each other even if you are several meters apart. And finally, the reader and the IT application software will be digitally communicating with each other and getting the billing done. So this is again another form of the figure. I'm just giving the more and more figure because you need to understand very thoroughly. This components of RFID again, the RFID tag, RFID readers, the scanning machine, and RFID antenna, which facilitates the transmission of signals. The working as we explained earlier, it's the same thing only. So there's a types of RFID, the two based on frequency bands and based on the power source. So two types basically we'll just go through quickly. The bottom figure depicts quickly the RFID different frequencies ranges. First one is low frequency, that is typically 125 kilohertz is uses is having the range of less than 3 feet, that's 1 meter. Then high frequency RFID, second line says high frequency RFID, typically 13.56 kilohertz is using it, and it is having less than 6 feet, almost 2 meter. And ultra high frequency RFID, third one is typically it's 433 megahertz. It is range is 25 plus feet. And the last and more foremost is microwave frequency, which uses 2.45 gigahertz. It is having range of 30 plus. This is based on the frequency bands. And based on the power source, we have again RFID, passive RFID, active RFID, as well as semi-passive RFID. So based on this, passive RFID is used in the library systems, control systems, and attendance making systems. Active RFID is used in the vehicle tracking, toll collection, asset tracking, etc. Whereas the semi-passive means battery assisted passive RFID. It is having the temperature monitoring as for cold chain logistics applications. So RFID basically uses these three standards. So advantages and disadvantages of RFID you can easily go through. It's a self-readable, automation, accuracy, real data, durability, and security. Okay. Active RFID is costlier. That's the main drawback of this RFID. And applications we have seen. Challenges also cost, higher initial cost to set up with everything. So that's they need to be addressed in future. And RFID and barcodes, basically, as I said, barcodes should be direct line of sight required for scanning. So RFID, it differs from the same thing, can identify individual objects without direct line of sight. And it requires a power source, whereas barcode does not have a need a power source. So you can go through this all those. The next part is wireless sensor network, WSN. It's a network of comprises of distributed devices. Wireless sensors is a set of devices, namely sensors. These devices with sensors are used to monitor the environment and physical conditions. Since all the nodes are wireless, so they communicate with each other through Wi-Fi or Bluetooth. So the only communication mode among all the sensor nodes is either Wi-Fi or Bluetooth because it's a wireless sensor network. So all the sensors are interconnected with each other with only with the wireless mode only. So see the WSN consists of several end nodes, and that means several source sensors and routers as well as coordinator. So the coordinator is the main picture, okay, which connects to the WSN to the internet. So sensors is the base one, a router on top of that one, and on the above all, the coordinator is the above all, which helps to connect to the WSN to the internet. So example is weather monitoring system, indoor air quality monitoring soil system, soil moisture monitoring system, surveillance systems, smart grids, machine prognosis and diagnosis. See the picture, it will be easily understand. See on top of that you have satellite and the left hand side satellites also. Satellites is being connected with each other, but there's a inter-satellite link, ISL. The bottom you see the WSN. WSN, there are two WSN, so left hand side WSN hash 1, WSN hash 2. So these are WSN networks are going to interact with the real-time world with the help of collection of all the sensors, routers, and one coordinator. And that one coordinator is nothing but the sync node. You see the red color? Sync node is the node, nothing but the coordinator. We have seen already in the Zigbee also topologies, the red color one is the coordinator. So same like that here, the coordinators is renamed as a sync node. With using the sync node is main thing going to connect to the gateway and to the internet. So vice versa, WSN2 also does the same thing. And also this base stations are connected using the cellular network. So this is the entire picture about the wireless sensor network. This is the same thing in deposits. And wireless WSN are enabled by wireless communication protocols such as Zigbee, Bluetooth energy, low energy, Wi-Fi, LoRaWAN, and 6 low WPAN. So these are the protocols mainly helps to enable WSN to be active. And the Zigbee, the standards, the typical coverage also is given, and also how it is used for a short range or high data rate or a long range. In everything is clearly depicted over in the below structure. And as we already explained, basic components, sensor nodes, sync bastions, communication network. These are the main thing which is comprised of the WSN. Sensor nodes, sensors, microcontrollers, radio receiver, battery. And sync and base station collects data from sensor nodes connected to the server cloud. Communication network is nothing but the wireless protocols, the Zigbee, 6LoRaWAN, or whatever we have studied already. And the types WSN is self-explanatory. Terrestrial means deployed on land, underground means deployed underground, underwater WSN means used in oceans, multimedia WSN means handles video and audio data, mobile WSN means sensor node itself or movable. These are the typical types of the WSNs. And I mean the last one is the applications of WSN is it where from agriculture to industry to even the urban planning all to healthcare also, even military border security forces also, everywhere this WSN is playing a major role. And since it has the advantages of wireless communication, no need for wired infrastructure, that's the main thing. And scalability, large number of nodes can be added. What are the disadvantages of WSNs? It has some limited processing power, limited battery life, and limited bandwidth, some security issues. So these are the main applications, advantages and disadvantages of WSN. So hope I covered these two topics, and rest of things we will see in the next class. And this is the textbooks and reference books which I have used for my structure. Thank you.